Hello everyone, hope you all are doing well. So now we will start our next topic, that is radioactive and ordinary ray stability and factors of nucleus. So talking about radioactive ray, it is having a shorter wavelength and have high energy level produced by a nuclear change or nuclear phenomena, a change in number of protons and neutrons in a nucleus. Obviously that proton and neutron is a nucleus, like this is a nucleus, in that we are having proton and neutron, and this is the electron shell. Okay, so it is having a shorter wavelength and it produces a ray. Nucleus produces a ray with a nuclear change or nuclear phenomena, and its change in the number of proton and neutron is called a radioactive ray, which is having a shorter wavelength and high energy level. Secondly, we are having ordinary ray. It is having a in an electron and having a longer wavelength but low energy level. We have done previously that which is having a longer wavelength having a low energy level, shorter wavelength having a high energy level. After that, it produced by a chemical change in an or not chemical formula phenomena. We can write I would write to write here that or chemical phenomena, sorry by the mistake I am written over here. After that, it is happening in the number, changing in number of electrons. Like if we are having 3 number of electron I am having over here, so it will got stable on K, L, M and shell, like 2, 8, 18 or 32. So it will lost it 1 electron. Okay, and there will be the 2 electron remains. So it got stable with the ordinary ray, happens in the number of electrons. Okay, let's move further. After that, we are having nucleus. There are the two types of nucleus, stable and unstable. For stable nucleus, having a magic number of protons, like a nucleus got stable on these magic numbers. That numbers we have to remember, like a number of electron got stable on these numbers K, L, M, N, 2, 8, 18, 32, and the number of protons will got stable on 2, 8, 20, 28, 50, 80, 126. Okay, and they don't produce radioactive ray and will not do reaction, because these nucleus is an already stable nucleus, so it will not do any reaction and not produce any radioactive ray. But if we are having a proton to 100, okay, so the atom will make its nucleus is stable, means it means it's having a 1800 protons, but here in a magic number we are having 2, 8, 20, 28, 50, 80 or 126. Thus these numbers are stable, not 100. So what it will do, it will do a reaction, okay, and also release radioactive rays with the reaction, and got stable on proton 80, because before 100 we are having 80. If it will 128, so it got stable on 126, but now it's having 100, so it will lose its electron by radioactive rays by reaction and got stable on 80. And now here are the few factors of this nucleus. One is the magic number of proton that we have done over here, we have to remember this. Secondly, we are having neutron proton ratio, like if we are having we can take carbon. Okay, carbon having mass 12 and atomic number 6, so its proton is 6, its electron is 6. Okay, its electron and proton both are electron and proton both are 6 6. So number of neutron is also number of neutron and number of proton is 6 6. Wait, okay, number of proton and number of neutron both are 6 and 6 over here. So it means because of equal number of proton and neutron, it got stable, it got stability. Okay, number of neutron proton ratio means which one got a same equal number of neutron and proton, it will also got stable, okay, in the neutron proton ratio factor. But if we are having radioactive carbon like 14 and 6, okay, so here proton is 6, but what happens, neutron is 8, so there is a difference in both number, it will got stable, so it will do reaction. It means this radioactive carbon is unstable and this carbon is stable. And after that, third factor, we are having graph factor. Graph factor we will discuss in next video. Till that, understand this one lecture. Hope you understand. Thank you so much.